Hi, welcome to today's lesson. Today we're going to be talking about the periodic nature of trigonometric functions. Trigonometric functions display something called periodic behavior. In other words, the values of trig functions repeat over and over. These are seen in the real life by sound waves, light waves, AC current, tides, moods, etc. Let's take a look at the periodic nature of a sine curve. With a sine curve, remember sine is the same as y. So I've drawn my unit circle here, and I'm looking at the y coordinate as theta changes. Along my independent axis, I've got theta, and I want to know how does y change. Well, when theta is 0, I've got a flat angle here. When theta is 0, the y is down at 0, so I have 0, 0. When theta moves to 90 degrees, or pi over 2, my y-coordinate is 1. My coordinate here is 0, 1. My y is 1 there. So at pi over 2, I go to 1. When I have 180 degrees, or pi, my y-coordinate again is 0. Up and down 0. So at pi, I'm at 0. At 3 pi over 2, or 270 degrees, my y-coordinate is negative 1. So at 3 pi over 2, I'm at negative 1. And I come back here to a y-coordinate of 0 when I reach 2 pi. Well, if I think about graphing the theta on the independent axis and looking at the change in sine, or the change in the y-coordinate as theta changes, I'll get a curve that looks like this. 5 points that you want to know are 0, 1, 0, negative 1, and back to 0. Please memorize this for the sine curve. For this sine curve in red, I've drawn the cosine curve. What is the cosine curve? The cosine curve compares to the x-coordinate of the unit circle to theta as theta changes from 0 all the way around back to 2 pi. So we see the x-coordinate goes from when our theta is down here at 0, this point is over 1 up 0, so we see that the x-coordinate is 1. At pi over 2, our x-coordinate is 0, so I go to 0 there. At pi, or 180 degrees, we're over at negative 1 in the x direction, so I see as pi, negative 1. At 3 pi over 2, our x-coordinate is again 0, so I put a 0 there. And as we reach around again to 2 pi, my x-coordinate is again over positive 1. So 1 is my x-coordinate at 2 pi. My points are 1, 0, negative 1, 0, and 1. Those are my 5 key points. The cosine curve goes down and up. Please, over the domain, 0 to 2 pi, remember this curve. Notice cosine with nothing on it goes from a maximum of 1 to a minimum of negative 1, as does the sine curve. Let's take a look at the tangent function. Remember, tangent of theta is sine theta over cosine theta. Well, this cosine theta in the denominator will give us a key to our asymptotes, because we know that the function cannot be defined when cosine theta equals 0, because that's in the denominator. Well, if you remember back to our cosine graph, cosine was 0 at pi over 2, 3 pi over 2, and etc. Notice the difference here is 1 pi, from pi over 2 to 3 pi over 2. So the period of this is pi for our parent function, tangent theta. And our graph goes from close to the asymptote at negative pi over 2 to close to the asymptote at pi over 2. Down here, close to the asymptote at pi over 2 to up here, close to the asymptote at 3 pi over 2.